Developing the natural base, E. This is 8.1 notes, pre-calculus. I believe this is video 4. Just to give us a little bit of context, this isn't nearly as odd as it's going to seem. We are all pretty used to the number pi, which is 3.14, let's say 2, round to 3 decimal places. The number E is similar in that it's an irrational number. Decimals never repeat and never end. And it is, I should more appropriately use the approximate sign. It is approximately 2.718. Now we know where pi comes from. It comes from taking the diameter of any circle. Let me rephrase that. Take the circumference of any circle and divide it by the diameter, and that gives you pi. E, it comes from this limit right here. If you take the infinite series, which in this case is written as a limit, 1 plus 1 over n raised to the n, and you keep making n bigger and bigger as it approaches infinity, this here is going to approach the number E, which is about 2.718. Just to show you how this works, if you were to put this into your calculator and then replace the n with a 1, and then a 10, and then 100, here's what would happen. If you put a 1 in, you would get exactly 2. If you put a 10 in, you would get 2.594. You put 100 in, you would get 2.705. If you would put 1,000 in, you would get 717. If you put 10,000 in, you would get 2.718. And as we continued to 3 decimal places, this would not give us the same answer as we continued, because the numbers that are after the 3 decimal places would be changing. But the 3 decimal places, this is the same as we continue. So this is just a snapshot of what this E is. You don't have to know any of this, but you should know what E is, the 3 decimal places. This number E appears in nature all the time. That's why it's called the natural base, because this number appears in nature. Remember one time I was walking in the woods and I heard a crackling behind me and I was startled and I turned around and there was E just hanging out, eating an apple. I'm like, what's up? And he's like, what's up? And then I left because it was weird. Just a reminder of the change of base formula. This change of base formula, when you change the base, you can change it to whatever you want. Typically, we're going to change the base to a 10, so it's a common log, or we're going to change it to an E, so it's a natural log. So here's what I would like you to write down. Log base E of x can be written as natural log of x. Now I know this isn't written in the order of natural log and L, so I like to think of it as log al naturel. See what I did there? If there's no base written and it's an ln, the base is an E. If there's no base written and it just says log, then that means the base is the common log, which is 10. So we're supposed to use this change of base formula for these here, and we're supposed to, in this column, use common log, and in this column, use natural log. So this first one would be common log of 20 over common log of 3. Using natural log, we would have natural log of 20 over natural log of 3. And in both cases, our calculator would give us the answer of 2.727. Once again, this is saying 3 to what exponent is 21. 3 to the second is 9, 3 to the third is 27, so we're looking for an answer between 2 and 3. The second one, if we use common log, it would be common log of 1/16 over common log of 2. If we use natural log, it would be natural log of 1/16 over natural log of 2. In both cases, your calculator should give you a -4. 2 to what exponent is 1/16? What's to the -4th? Last one is log base 5 of 15. That would be common log of 15 over common log of 5. That would be natural log of 15 over natural log of 5. In both cases, that is about equivalent to 1.683. Technically, each of these equal signs should be approximate symbols. So E appears in nature, and it's used for the base of a logarithm a lot. 10, because we have 10 digits, it appears in human fingers. It's a number we use a lot, so we use the base 10 a lot with logarithms. That concludes video 5, and we have one more after this, which we're going to be solving some equations with logarithms.